Can we find the area enclosed by 3 different points in 3D space? And notably, these 3 points are going to be on the same plane. So the first thing to notice is whenever you have 3 points in 3D space, they have to be on the same plane. So that's called being coplanar, and here we see that they're on the same plane. And the idea here is, well, if they're on the same plane, 3 points on the same plane are going to form a triangle. So here we have this triangle, and can we find the area enclosed by this triangle, or the area of this triangle? And so maybe if I look at this from the right direction here, then we can see, okay, there's going to be a triangle, and I want to know, is this, what is the area of this triangle? Well, there's no apparent way to do this, just because we'd have to, if this was on 2D space, we could easily do this. We could calculate this with the formula of a triangle, and we just find an angle and be good to go. But there's a very efficient way to do this in 3D space using vectors. And so the first thing I'm going to do is take a vector. This is the vector PQ, starts at P and ends at Q. And then I'll look at the vector PR, starts at P and ends at R. So these two vectors seemingly form 2 sides of my triangle. And the property here that we can use to our advantage is that if we take the cross product of these 2 vectors and then take the magnitude of the cross product, so the cross product will give us a vector, the magnitude of that vector is going to be equal to the area of the parallelogram spanned by the vectors. And so this is what that parallelogram looks like. And the question is, all right, we don't want the parallelogram, we want the triangle. How do we get the triangle? And that is as easy as dividing by 2. So you can see the triangle here is exactly half of the parallelogram. So if we take the magnitude of the cross product and divide by 2, we will get the area of this triangle. Make sure to like and subscribe and let me know what you want to learn next.